Now we are coming to this another lecture for memory write timing diagram. As I told you earlier that memory read, memory write, both timing diagram both needed 3 T states, or 3 T states means timing state, 3 timing state, 3 numbers of timing states required. So same fashion we have taken T1, T2, T3. These are memory write machine cycle. Right, the memory write machine cycles. So in the clock again we have taken the clock pulses, the frequency for a particular time period. This again. Now again 8 to 15, it is also very easily you can get understand, because already in the previous lecture I told you about this timing diagram of code fetch, memory read. Now memory write will be much clear for you. This again higher order address byte. So T1 to T3 region, because no T4 is there, so undefined is not needed here. Again 80 to 87, this is the multiplexed bus. So for this multiplex bus, obviously you have to take this first lower order address byte. Then T2 to T3. Why there is no such kind of gap? If I talk about this previously, I have taken this memory read operations. There we have shown a gap. Why? Because again whenever you are providing this address byte, and then to read it from the memory, mind it very clearly, to read it from the memory we need some time. So that is why there is a delay, and this is dotted line means it represents a delay, we can say, right? See here we have not given any kind of delay, because as soon as the memory means microprocessor is writing the data, so microprocessor itself decoding the instructions and they are actually providing the data directly. So that is why there is no kind of delay, no amount of delay here, or if it is a delay, there is very less amount of delay, or is we can say the negligible amount of delay is here. That is why directly we have connected it. So be clear with that. Majority of the students, they do mistakes here only. While writing the memory write, they also provide this kind of gap, but don't do this, is not the right thing. You don't need to provide any kind of delay. It will be taken directly, right? And ALE, the same thing. ALE will be enabled only on the T1 state, in the T1 state or first time state of any kind of machine cycles, and then it goes to low. Just to enable means just to take the lower address byte, and then read bar, as because this is a not a read operation, so we will take only high. That means if I put read bar equals to 1, so 1 bar equals to 0. So low enabled signal here, we are giving the high enabled signal, so it will be not enabled, it will be disabled here. But here we are doing the memory write operation, so obviously WR bar equals to 0. WR means write. So here write and read will be taken, read and write, both the operations will be taken place in between the T2 and T3 states of any machine cycle. And I remember, as because this is also a memory operation, so memory operations remember, if we put 0 low enable signal, so IO input output will not be activated, only memory will be activated here. So IMR will be 0 and S0 S1, here S1 will be 0 and S0 will be 1. So I hope this you got the total how this opcode fetch, memory read, memory write individually I have shown. Now whenever I will do a complete instruction just like MBIA, 07H, LDA, STA, so you will get the more coverage. Thank you very much.